Welcome to day 5. We're working more with calculus, specifically the derivative, and we're going to look at graphs and see how we can use the derivative to describe graphs. And we're going to look at the first derivative, which actually we've been working on already, and we're going to look at something called the second derivative in its applications. So again, another name for the derivative, slope of the tangent line, f prime, y prime, dy over dx, and because it just has one little tick mark, f prime is known as the first derivative. So f prime is the slope of the curve at any point, slope of the tangent line. So what we're going to look at are certain values for f prime, just by looking at graphs. When f prime is positive, or when f prime is equal to 0, these are called critical points. Something special has to happen here. For what we're going to be doing today, those will be local mins or local maxes on a graph. Okay. The other part is, if f prime is positive, that means the slope is positive. That means a function is increasing. We always read left to right. And if f prime is negative, that means the slope of the graph is negative. That means the function is decreasing. I think we've already, you already know this thing. Positive slope means the graph is going uphill. Negative slope means the graph is going downhill, and so on and so forth. Now we're going to use our derivative ideas and nomenclature to describe these ideas. Now the other thing we're going to look at is the second derivative. So the second derivative, let me grab a different color, is called f double prime. F prime is with one tick mark, f double prime has two. The second derivative is the derivative of the first derivative. So f double prime is the slope of the slope, or the slope of f prime, or f double prime is the rate of change of the rate of change of f. How can we make it better? The second derivative is concavity. It tells me the curvature. When f double prime is equal to 0, this is where the graph is neither concave up or concave down. It will be our inflection point. It's where it changes concavity. When f double prime is positive, that means we have things that are concave up. And when f double prime is negative, that's when we have things that are concave down. F double prime being positive means f prime is increasing, or the ROC is increasing, and f double prime being negative means f prime is decreasing, or the ROC is decreasing. And we talked about these in the third quarter in Unit 2. So let's draw a curve whose ROC is positive and at an increasing rate. Well, that would be something like this. It definitely has a rate of change or slope that is positive and is at an increasing rate. So f prime, which is slope, it's definitely positive, and f double prime, which is concavity, it is positive because it is concave up, and this is positive because the function is increasing. Let's draw a graph whose ROC is positive at a decreasing rate. It would be something like this. It's definitely positive, it's going uphill, but is decreasing. It is at a decreasing rate, so f prime is still positive because the function is increasing, and f double prime is negative because it's concave down. So if you think about what we did earlier in Unit 2, we talked about f, ROC, and concavity. Now we're going to go f prime, and f double prime. Now I want to draw a curve that has a rate of change that is negative at an increasing rate. So negative means it's going downhill, increasing rate. It means it's getting less negative. So again, f prime is negative because the graph is decreasing, and f double prime is positive because it's concave up. And finally, a graph whose ROC is negative at a decreasing rate. So something is downhill with a negative slope is getting more negative. I got negative negative because this function is decreasing. and f double prime is negative because it is concave down. So I'm going to be able to look at a graph and determine if f prime, and f double prime is positive, negative, or 0. That's all I care about, those three things. So f is the y value, f prime is the slope, and f double prime is its concavity. These are the three things I'm looking for. So let's do the y value. At point A, the y value is positive because it's above the x-axis. B is negative, C is positive, D is positive, E is positive, and F is positive. And the reason this is this is above the x-axis, this is below the x-axis, and so on and so forth. Let's talk about the slope. Well, when I do slope, I could think about drawing little tangent lines. So if I drew a little tangent line here, that is negative. If I drew a tangent line here, it is equal to 0, that slope. The tangent line here, positive. The tangent line here is 0. The tangent line here would be negative. And a tangent line here would be 0. And the reason why this is happening, the reason why f prime is negative, because my function is decreasing. Why is it 0? Because this is the local min. Positive because my function is increasing. 0 because it's a local max. Negative at e because my function is decreasing. And at 0 at f because this is a local min. And then finally, I could do concavity. So the one thing I should note is where is the inflection points. For me, I see inflection points probably right here and right here. Inflection points are never at a min or max, they're always in between somewhere. So to me, point C and point E I would consider inflection points. So when I see the graph, I see point A and point B being on the concave up part, C is in the middle, D is on the concave down part, E is in the middle, and F is on the concave up. See, it's curving up here, even though we don't see the whole graph. So for me, A and B are going to be positive because they're concave up. D is going to be negative because it's concave up. F is going to be positive because, D is going to be negative because it's concave down. F is going to be positive because it's concave up. And C and E are going to be 0 because these are inflection points. A and B are positive because they're both concave up. D is negative because it's concave down, and so on and so forth. Okay, we're going to do the same thing. F is the y value, F prime is the slope, F double prime is the concavity, and the y values are very easy for this one. All 6 letters are positive because they're all above the x-axis. Now for the slopes, if you want, you could draw little tangent lines, and in pink I'm drawing little tangent lines. Okay, so A has a positive slope, B has a 0 slope, C has a negative slope, D has a positive slope, E has a 0 slope, and F has a negative slope. And the reason for all this is function is increasing. This is a local max. Function is decreasing. Function is increasing. This is another local max, and F is the function is decreasing. But you don't have to state the reasons. And then finally, the concavity. Well, I'm going to note the inflection points. I think C looks like an inflection point. I do not think D is an inflection point. I would say it would be somewhere higher up. I think those are inflection points. So to me, A and B are concave down part, curving down. C is in the middle, D is concave up, and E and F is concave down. So A and B would be both negative. C would be 0. That's my inflection point. D would be concave up. E and F would be concave down.